Good morning. Welcome to the first NDC Sydney. I'm very excited to be in Sydney. This is my first time in Australia, so it's a long way. It's a long way from the UK. I left on Saturday. I got here Monday. Yeah, weird. So this is a talk called Centralized Logging Without the Blood, Sweat, and Tears. Okay. This is a talk based on the fact that I used to run extremely large logging clusters. Like, I think at one point my ElasticSearch cluster, when we talk about it, was like 10 terabyte, 14 terabytes of data at some point. So this is a talk designed on how to get started on much smaller scale, much smaller scale. So I'm Paul Stack. I got Twitter details and my email address at the bottom. If you want to heckle me, if you want to disagree with me, please get in contact and we'll certainly have a chat about it. I am an engineer at HashiCorp. Yay, I got a new job. If for anybody who doesn't know HashiCorp, they're the people that create Terraform and Packer and Vagrant and Nomad and Console and all these awesome tools. Come in and sit down, friends. I'm a reformed ASP.NET and C# developer. Okay, I don't mean that with any disrespect, okay, at all. I just do not work in the Windows environment anymore. I work in Go. I write Golang and I work in Linux. So I find myself that I can be a little bit more hacky with Go, as people who've used Go know. So I do that now. I'm a DevOps extremist. So I was a developer, moved into operations, and now I'm actually building operations tools for developers again. So bringing some experience reports into it, which is really good. And I'm a conference junkie. I think I've done like 13 conferences so far this year. I think while I'm in Sydney, I have like 4 talks, and then I go away to talk somewhere else next week. So I love this. So why centralized logging? Okay, this isn't a talk on why we should centrally log. Okay, there are many talks out there about centralized logging, okay, and why you should do it. One thing that we should agree on, or 2 things we should agree on, is central logs give us that single place to analyze our log files. Okay. And secondly, we remove the dependency on SSH in and RDP and into servers to find logs. Okay. You would not believe the amount of people I still speak to that have to RDP or go to their operations team and RDP into their server in order to get their logs. And as developers, that's extremely frustrating, okay? Because it creates an environment of, A, we probably forget to care about logs at that point, and we probably don't know what's happening in our infrastructure. We don't know how our application is behaving in production. The question to ask yourself as we go through this is, what happens if we lose a server overnight and that server was full of log files? How are you going to know why your application crashed or why your server crashed? Okay. As we go through this, remind yourself on that. If you don't use centralized logging right now, I'm hopeful that this will give you a little bit of code and a little bit of a kickstart in order to actually say, hey, look, I can deploy this infrastructure quite easily, and more importantly, very cheaply. Very, very cheaply. Mr. Murphy, he was a very wise man, okay? His law says anything that can go wrong will go wrong, okay? Does anybody in here claim that they've never encountered a bug in their production software?
Undocumented features.
Amazing. It's true, right? Every time we release our applications to production, they behave slightly differently to what we expect them to do. Now, this could be environmental changes. This could be configuration changes. Mostly, it's because of users, okay? Because the way users interact with our system is completely different to how we believe they interact with our system. So because of that, it's very important to understand that you must log, and errors happen. So because they happen, we should catch those errors when we should take advantage of that rich information, and we should actually be able to make our software better based on that. Is everyone in here software developers? Any QAs, ops people? Everyone's developers. Everyone Windows developers? No. Ooh. Oh, what languages have we got outside of C#?
That's good.
Excuse me? Go, excellent, excellent. You're my favorites already. Any raising on Go? Groovy. Is that still a thing? I'm joking, I'm kidding. I'm only joking. It is still a thing, and I have used it. And I actually really like Groovy, to be honest with you. And the interaction with Jenkins and Groovy is very useful. So I only say that in jest. Okay? Classic ASP. Wow. There's always one, isn't there? There is always one. You definitely need to centrally log, because that always goes wrong.
Exactly why I am here right now.
So one thing I found is you do usually say, or you usually find someone in the room who says, well, you know, my software works. It works as expected, and we maybe get the odd bug every time, okay, or once in a blue moon, okay? Those people are slightly delusional, because there's one of two things happening there at that point. They're either not aware that their application is throwing bugs, okay, or they're blinkered and they don't care that it's throwing bugs. Or secondly, they're kidding themselves because they have no single pane of glass in order to get access to their logs. Okay. Back to that hassle of having to file a request to your ops person who in 60 days or whatever their time frame in order to get to your request will be, of RDPing into a server and grabbing a file or FTPing the file down and then sending it to you. It's really messy. It's really painful. Again, what happens if you lose a server and the logs were only on that server? There are many logging tools now. There really are. Okay, Logs.io, Loggly, Splunk, Graylog2, Elastic. You can go on and on. Okay? The rise of DevOps has basically meant that you Google DevOps tools and you'll get hundreds and hundreds and hundreds of tools back these days. Okay? And the new way of the new hello world is either like new frameworks, new login tools, new JavaScript libraries. This is what we do now. We like to pollute the environment with extra tooling. There's lots of hosted solutions. You can have Front by Elastic, Loggly, Logs, Splunk. There's also free ones like Elastic as well. You can host it yourself. Graylog2, there's loads. Okay, check them out. I gave a logging talk, I believe it was like 2 years ago now, on how to scale a logging infrastructure to 1 billion messages a day. Okay? We have to get some terminology right. When I say logs, I actually mean messages. Okay, because a message can have a different type. Okay, it can be a debug message, it can be an info message, it can be a trace message, it can be an error message, etc. So we try and use the term messages because we like passing messages. Messages is a great way of exchanging information between our teams and our environments. So I wrote this talk on how to scale a logging infrastructure to accept 1 billion messages a day. For those who are trying to do the maths, that's about 11,500 messages a second. Okay. And it was a painful, horrible experience. It really was. And we started with a really simple infrastructure. Looking back, it wasn't as simple as I first thought. Okay. So on the top right-hand side, we have application servers. And we had forwarding or emitting agents on every application server. These were Windows servers back then. Okay. This was back when I was like, when I had hair. And we used, I believe we used NXLog, and we used specific JavaScript framework libraries that we used in order to forward from our Node.js applications and so on. And those messages were sent to a log processor node. Log processor nodes had 2 things on them. Okay, we had a cluster of 3. Every node had a Redis instance, and every node also had a Logstash instance. Okay, anyone know Logstash? Quite a few. It became very difficult because some applications would connect to Redis to send their messages. Other applications would send their messages directly to Logstash. And then we had to put some polarity in place in order to say, hey, if you forwarded it to Logstash, then send it into Redis so that we use that as a persisted queue. And then later we'll have we have the log indexer nodes, which will go and read the data out from Redis, and they'll broker the messages through into Elasticsearch. Okay. This was painful. Okay. For many reasons. Okay. Firstly, Redis. Redis is a persistent storage queue. Okay? We didn't realize, I can see some people shaking their heads. We did not realize, okay, that every time we were getting to the edge of our memory allocation in Redis, Redis was dumping the keys at the bottom of the pile. Okay? So it was first in, last out. So we thought that our logging infrastructure was like killing it, and we were like processing hundreds and hundreds of requests a second. Yeah, that wasn't the case. It took a long time to realize that, though. A long time to realize that. Secondly, we had Logstash here, and we had Logstash here. We had a lot of moving parts to this simple infrastructure. It was supposedly a really simple infrastructure, right? And internally, it looked like this. So the log indexers were sending data to Redis, or excuse me, the applications were sending data either to Redis or they were sending it to Logstash. Logstash was forwarding the data into Redis, and the log indexers were reading the data out of Redis and forwarding it on to Elasticsearch. Tire fire. Absolute disaster it was. And it got to the point where one day that we realized that we actually lost about 8 gigs worth of data per server when our Redis cluster crashed. Okay. So the CTO was not very happy, and he suggested that maybe we go back to the drawing board, as you can imagine. What we actually did, if we go and have a look at the infrastructure right there, this was a cluster of servers, and this is a cluster of servers. In order to get the data from the application servers into Elasticsearch, per data center and per environment, we introduced 6 new servers. 6 new VMs. They were pretty beefy VMs. They were like 16 gig RAM. They were like 250 gig hard drive, and they had like 8 cores. Okay. This was in a physical data center. So we were like using up resources pretty fast. We had 16 environments, and we had 4 data centers. So we were like churning through money for a simple infrastructure. What did we do? As developers, we went and complicated it again. That's what developers do. Okay? Now, bear with me. There are a lot of moving parts. In this time, the application servers sent data to the log processors. We introduced Apache Kafka because it was cool back then. Well, it's still cool. It is still very cool. What I mean is, it was new. I think it was actually like Apache Kafka 0.6. Okay, I think it's 0.9 now, if I remember rightly, somewhere around there. So Apache Kafka was reading the data out of the log processor nodes. Of course, it was having to store its offset in the Zookeeper cluster, and it was passing. We were using Kafka as a persistent storage. Okay, so we thought, right, how do we get the data from Kafka into Elasticsearch? Let's use another Kafka indexer. So we introduced another level of Kafka indexers. Okay? We had to reduce the polarity right now. This was pretty successful. This is how we actually scaled to about 11,500 messages a second. Okay? We were churning through like 4 terabytes of data right now a day across all of our environments and across all of our data centers. And we had one centralized place, so we had this same environment 16 times. And we were using Kafka Mirror Maker to move the data between all the environments into the central logging system. So if you think of 16 of these all around, okay, this was expensive, really expensive. Just to give you an idea of how expensive it was, the Elasticsearch cluster in AWS was 140 R3 extra large nodes. 140. And each one was using a 1.5 terabyte EBS volume. This was crazy. But they loved it because it could handle any messages we threw at it. Now, the reason I'm giving this talk is because companies can't afford this scale. Right? We couldn't afford this scale, looking back. We were burning through money. The Elasticsearch cluster alone, I believe, was costing us about $25,000 a month, just for Elasticsearch. Okay. Now, in order to get the data from the application servers to the Elasticsearch clusters, we had 3 Kafka nodes, we had 3 log collector nodes, or log processor nodes, we had 3 Zookeeper nodes, and we had 2 Kafka indexers. So we went from 6 servers, and we were now on 11 servers. So 11 servers times 16. That's 171 servers just pushing data around. Okay, not storing it, not doing anything with it. This was ridiculous. But in order to do it, we had to, again, reverse the polarity inside our log processors. So the applications were either logging to Redis or they were logging to Logstash, as expected. But we changed it that Redis was no longer the queue. Okay? As soon as it went into Redis, Logstash was pulling it immediately out of Redis and sending it to Kafka. Kafka is designed for this. Okay? Kafka is designed for this major message overhaul because it remembers the order. It's strongly ordered. It remembers the order in which you pass in. It gets out in the same order. And it has lots of brokers that it can read really fast, and it can use in different partitions. It can spread the load. So it worked really well. The trouble with it is there were just so many of them. PagerDuty was never ending. And I do mean never ending. There has to be another way. If you're a small company, there's no way in hell you have enough people and enough money to manage an infrastructure like this. We had a team of 6 people dedicated to our logging, metrics, and monitoring infrastructure. Does anybody in this room have that level of resource for their metrics, monitoring, and infrastructure? It's crazy, right? So, looking back on this, like I don't work at that company anymore, and this is not a case of slagging off. This is a case of, as developers, we very much overcomplicated it. So over the past couple of months, I've been really looking at different ways in order to do this. We're going to use 3 simple tools in AWS. Anyone use AWS in here? Awesome, more than I thought. Anyone use any other cloud providers? Oh, even more. Which cloud providers? So I've been told that you have to opt in here to use the Australian Azure data center. Is that right? No? Okay, maybe it's on your account by default. There's 2 data centers. Excuse me? There are 2 data centers. There's 2 here, okay. That's because one regularly falls over. This is not serverless. Okay, I put a joke tweet out there last night saying, look, I've just built a logging infrastructure serverless. Okay, it had 108 retweets and likes. Okay, because serverless is cool. This is platform as a service. This is very much PaaS. Okay, I understand that Lambda is in there and Lambda is serverless. Everything else is just using PaaS-based tools. So the way it works is application servers send data to a Kinesis stream. Anyone know what Kinesis is? So Kinesis is like, if you think of it as a very simplistic Kafka, okay, based in AWS. Okay? So you have a number of shards inside the Kinesis stream, and the number of shards relates to how fast you can read and write data out of it. Okay? And we'll talk about the metrics. Okay? But it has a persistent queue, and it stores data, it retains data for a period of time that you determine. Okay, I promise you we're going to get to some code. It's not going to be me just telling rubbish tales for the next 30 minutes. So from Kinesis, we have to actually take the data and we have to push it to ElasticSearch. What better way of doing that than Lambda? Okay, Lambda is ridiculously cheap to do this type of thing. Okay, so we have a tiny, like an application invocation, which goes and reads data in batches, pushes it into ElasticSearch. This is all hosted, and I could do all of this in infrastructure as code. I like this. I don't like clicking around in UIs. Code time. I think somebody was taking a picture of that. Do you want that back? The code's available, I promise. So I'm going to use Terraform for this, not because I work at the company. I was an OSS maintainer of the code base for quite a while before I joined the company. So this is not a sales thing at all. You could use CloudFormation for this really easily. You could also use another tool called SparkleFormation. And there are like lots and lots of infrastructure as code tools. This is the one I use on a day-to-day basis and have done for about 18 months now. It actually just went 0.7 today, which is like, this is all new features I'm showing you, by the way. So if that didn't get released this morning when I woke up, we'd have been using a dev branch. So let's look at it as follows. Anyone any questions so far? Anyone care? I'm kidding. Everyone at the back read that code? Excellent. So, did I just delete something? That's never good. Okay, perfect. So we declare a provider. Okay, Terraform has built-in support for many cloud providers. Okay, Azure, Google, DigitalOcean, Joyent, AWS, of course, lots and lots of other ones. It's got vSphere, VMware, or vCloud Director. It's got like, there's tons of support. It's very easily extendable. There's another talk of mine out there that you can go and have a look if you really want to extend it to your own purposes. So we declare a provider of AWS and we give that a region. So we tell Terraform what region we want to deploy our code into. Of course, I'm using some technologies that are not generally available across the board in all regions. So you'll have to bear with me in the fact that some of these are not in Asia-Pacific data centers, but I believe they are going to roll out later this year in some of them. So we're going to start with the provider. We're going to create a module. Okay? Modules are reusable pieces of code in Terraform. Think of it as like a third-party helper library that you have an interface for, and you just push values into, and it will actually allow you to reuse the code again and again. So we're going to create a module called LogStream. And the source of the module, I'll show you the source right now, is a Kinesis module. Very simple. We're going to give it a stream name. We're going to give it a retention period. And we're going to give it a description. We're going to talk about shard counts in a second. Okay. Now, the module looks as follows. We have an interface, as we like to write documentation. We never like to write documentation. We're developers. What this allows us to do, it just allows the user of the module in order to actually understand what the variables are for. Really simple descriptions, and there are lots of tools out there that will go and grab those descriptions so that when you're writing Terraform code from the command line, it will prompt you and say, the value that you need now is for this. Okay, it's really useful. We set some defaults. Retention period by default is 24 hours, so 1 day. Reason being is that it's slightly more expensive for the longer retention periods in Kinesis. So if you want to like cheap out, then set a shorter amount of time. Let's be honest. If you're not processing your logs within 24 hours, you've probably got different problems. So 24 is probably okay. And then lastly, we have some outputs. We need the ARN. So the Amazon resource number. We actually need that value to be able to pass on around in different places. And how it looks in the code is we declare a resource, name, shard count, retention period. We want to capture all of these metrics right here. Okay, we want the incoming records, the outgoing records, the incoming bytes, outgoing bytes. We want the iterator age in milliseconds, so we understand how long it's taken to churn our records. This is all documented. Right? I'm not breaking any amazing discoveries right now. This is all in the AWS CLI and SDKs. Okay. We set some tags, and that's it. That is the simplest module in Terraform that you can probably imagine. Actually, I have a simpler one. But it's really easy. It's really readable. Okay. I understand that we have some notation here of some interpolation values for var dot. That's as complicated as our config gets. So we declare it as follows. So if I wanted to create another log stream, I can go and do that. So let's go and create an environment just so you can actually see it in place. We're going to call this Sydney. just want to show you how simple it is in order to actually call this code. But I'm going to copy and paste, like every good developer does. Test stream. Shard count 1. So Terraform has some built-in commands that come with it. Again, this is not a Terraform demonstration. This is just showing you that using really simple infrastructure as code, you can build this type of logging infrastructure. The code will all be available. So if we run the command terraform get, so go off and get me the module source. Modules don't have to be on the same machine. They can be stored in GitHub so that your sysadmins can be taking care of these modules, or your infrastructure team, and you as a developer can just be coding against these modules. So we're going to go off and get it, and it's gone and got it. Okay. As it's local, it just creates a symlink. It doesn't do anything like really crazy. And if I run, you can see it creates a .terraform folder right here, and there's a copy of the module source in there. So you always know what version of the module you're running against. And if I run the command terraform plan, it's going to, Terraform is built on graph theory. Okay? Terraform will work out the dependencies between all the different pieces of your infrastructure and actually plot in what order they have to be created. Okay? And sometimes you'll see values like this computed, because those are values that come back from AWS and we don't quite know what they are. Okay? But mostly you can read it and you can see what it's going to do. And at the end, it actually gives you a nice little plan, and it says plan 1 to add, 0 to change, 0 to destroy. If we go to Kinesis, we'll see Logstream. I had to prepare my demo earlier because the Wi-Fi in the hotel has been pretty shoddy. So we'll look at the actual infrastructure in a little bit. This is just showing you that we can deploy it really quickly. Right, so there's nothing in there for NDC Sydney or for Sydney or a different log stream. There's only one stream in there right now. So Terraform apply. What this is doing is this is taking a snapshot or working out what the infrastructure of my local machine is like, comparing that against the environment that I'm going to deploy it to, in this case AWS, and it's going to tell me, hey, I need to make these changes to bring the environment up to the same speed. Okay, so it's a deterministic way of keeping your environment in exactly the same configuration. This is a good thing. This is a very good thing. And you'll see it's creating, and it gives you some output and says it's still creating, just because the AWS SDK is, I'm actually going to Oregon here, so it's a little bit slower than I would expect. But it's going to go and create it, and if I go back to the AWS CLI, we can see that test stream is actually active. So Terraform is just going to tell us now that it's created. Hopefully, if it doesn't crash. And we can go and have a look at it. Oh, it's currently updating, that's why. So it's not at the state that that Terraform expects it to be at. Terraform expects it to be at the state available, so available to use, and it will hold the connection open to that until it's at that point, because that's what we tell it to do. Yeah, you can see it's still updating. And eventually, you'll get a configuration. So I've used the same Terraform module to deploy to 2 different Kinesis streams. So you can see it's a really simple wrapper around Terraform that allows us to pass code in. Before modules were created in Terraform, you would have had to copy and paste all of that code. Okay. I know we are happy with copy and paste. Not like that, we're not. Definitely not like that. And of course, if I really wanted to deploy it to a different region, I could just change the region, and it would go and would deploy my infrastructure to a different region. Now, I said to you that Terraform uses graph theory. Let's have a look at what that means. I can run the command terraform graph. Go off and graph all the pieces of my infrastructure and tell me the order and tell me how they relate to each other. And it looks like that. That's garbage. You can't read that. No. So this time we're actually going to pipe it through a tiny application. I'm really sorry. We're going to pipe it through an application called Dot. Okay, it's a tiny package that sits on Mac, and we're going to save it as a PDF so that we can actually have a look at it. And if I say opengraph.pdf, we can see that a Kinesis stream depends on the provider AWS, which depends, because it's a module, this is the module base right here, it depends on the overall infrastructure in AWS. Okay, really, it's not really groundbreaking because there's no nodes interacting with each other. We'll have a look at that in a little bit when we start to build all the infrastructure together. I have 30 minutes. This could be interesting. So Terraform destroy. Do you really want to destroy? Yes, we do. And it will go off and it will tear down the infrastructure as we expect. Disposable environments. Anyone have long-running QA environments? How costly are they? How out of date are they, more importantly, right? It's a QA's worst nightmare when they have to like go and say, hey, can you like update our environment? We're like 18 security patches behind on Windows. Or it's been telling us for a week that we have to reboot. Your infrastructure can be brought up and destroyed at any time. I understand that I'm showing you stuff built into AWS, but if you're in VMware, or you're in vCloud, or you're in Azure, the same thing can happen. It's all there, it's all available. And then we can see, we get a nice little output at the bottom. It says, 1 destroyed, 0 changed, 0 added. The apply is complete. If I go back, I refresh, and one of them will disappear. Excellent. That's Terraform 101. We're going to push on. Let's kill that, and let's kill that. So I have a module for Kinesis. I also want to store some information in an S3 bucket. Okay. Anyone use Lambda? Okay. There are different ways that you can use Lambda. Okay. One, you can open up the editor and you can copy and paste the code directly into the code editor. Okay. 2, you can upload a zip file, so if you package it locally. Or 3, you can use an S3 bucket. And it will work out the difference based on the E tag, so based on the version of the S3 bucket object, and it will update your Lambda configuration every time based on that. So we have a really simple bucket. I did say this module was simpler. That's it. It has a bucket, it has an ACL. Whether you want to force all the objects to be destroyed inside the bucket before you delete the bucket, and whether the versioning is enabled. Okay. I don't even think it gets simpler than that. I'll struggle to find one that's easier, I promise you. So we have a Lambda, we have a module for the bucket. We declare our Lambda function. So this is a new feature in Terraform 0.7 where you declare data sources. Okay. Before, you'd have had to use template files and stuff like that. Now what it does is it will hold that as a data source, and it will allow you to share that data source between different pieces. We still have, this is our entire Lambda function right here. This is thanks to an open source library from AWS Labs that will allow you to go and experiment with this. So the copyright is all still there, the license is still there. But it basically has three variables that we pass in. Okay? The region in which the Lambda needs to be deployed, the ElasticSearch endpoint that we actually have to push the data to, and lastly, the index that we want to push data into in ElasticSearch. Okay? Everything else is just like simple Node.js. Actually, it's not simple Node.js. I can't read JavaScript, so it could be doing anything for all I know. If this was Python, I'd be as happy as anything. But all it's doing right now is reading batches of information from Kinesis, and it's pushing them through this Lambda, and it's actually pushing them out into Elasticsearch. It's ingress and egress. Okay, just think of it as based on that. So what we're doing is we're actually going to say, hey, go off to this template file, substitute in these variables, and then that's then available to be used within anything that actually needs that JSON. In this case, we're actually going to zip the file up because we want to use the zip file in S3 in order to deploy our Lambda. So there is a little resource type called archive file, which you pass some source content into. But look, we have a really nice data interpolation here of data.templateFile.lambda function, but But the main thing is on the end.rendered. Go off and render that template for me. Go and build that actual JS file. And then save it as lambda.zip. And you'll see we have a lambda.zip right here. And inside that, it has lambda, Kinesis lambda es.js. So it's actually built it for us. And if we look at it, we will have substituted in the variables. I haven't done this. This is doing it for me, I promise you. So it builds it for us, and it's allowed. I'm specifically doing these out of order because I'm going to show you how Terraform builds the graph the whole way through. So right now, we have a Kinesis stream. We have an S3 bucket, and we have a JavaScript template that we want to do something with. In this case, we're actually going to upload that Lambda source, that JS template file, up into an S3 bucket, and just so that it's available in order to be ingested from Lambda itself. Now, the interesting thing, the Lambda function. Lambda functions, it took me a little while to get my head around them, to be totally honest with you. Okay, because not only do you have to declare the resource, but you also have to use IAM on it. Okay, who likes IAM? No one. It's really complex. It's really horrible. Okay, so for those that don't know what IAM is Identity and Access Management in AWS. So it allows different people and different processes access to different pieces of your infrastructure. So for example, an S3 bucket. We ideally do not want that S3 bucket to be publicly available if it's got sensitive information in it, or if it's got some of our application code in it. What we would like to do at that point is we would like only specific access from either specific accounts or specific nodes or specific services. So like if we have an S3 bucket that we're pushing code to, the only thing that should be able to read out of that is maybe Lambda. Okay, so that's what Identity and Access Management is. It's in JSON. That's the best language for writing stuff. Okay, so if we go and have a look at in the Lambda function, we'll come back to that. So the Lambda function is really simple. Okay, we declare an S3 bucket, an S3 key. We give it a function name. We give it the role that needs access or that has to act on the Lambda function itself. And we have a handler and a timeout. Okay. Now let's have a look at what the actual role is. Firstly, you need a role, an overall role that you can attach policies to. So this is saying that this specific function is for Lambda. So you have a principal and a service, which says that the actual Lambda service is lambda.amazonaws.com. But we want to attach extra policies to this. So we want to attach ES star. I would never use star. This is just a demo, okay? You can have like ES describe, ES get, ES push, all of these different things. I'm just saying that Lambda has access to do anything inside my Elasticsearch cluster. It's probably not the best demo to give. If you're going to use my code, don't do that, please, don't. But I also wanted to be able to do all bits and pieces of Kinesis. So we want to read from Kinesis. We want to read from Kinesis. We want to change the iterator in Kinesis. And we also want to like list the shards inside Kinesis to see what's available and what's not. So you attach that policy to the role. And we end up with, in IAM, IAM for Lambda, and the permissions are as follows: ES star, Kinesis star on all resources inside it. Okay, so that's going and it's deployed it for us. Great. So now we have a Lambda function, okay, that can read from Kinesis. So we've actually built most of our pipeline right now. Next, we actually need to tell it what's it reading from. Okay, so you have to tell Lambda what the data source is. Okay, data sources in AWS are things like DynamoDB, Kinesis, Redshift, S3 buckets. If you want to log directly to S3 buckets, that's fine as well. But so you just give it, in this case, the ARNs. Okay, go off and give it the ARN for the Kinesis stream, and give it also the Lambda function ARN, and that's going to create the link between them. And we can go and have a look at how that actually does that inside Lambda in my function. The triggers are there. So you can see that this Lambda function is connecting to the Kinesis stream called log stream on this ARN. And the batch size that we want to pull from is 100, and there are no records processed because there's nothing in that function right now. Okay, there's nothing in there. But you can add triggers and you can do all sorts of stuff. Now we get to the interesting bit. ElasticSearch. Who uses ElasticSearch? Not many. Not many. A little bit. Okay. ElasticSearch can be a beast. It can be as difficult or as easy as you make it. Okay. I love ElasticSearch so much. It makes my life really simple. And what makes my life even simpler now is the fact that Amazon have just released support for ElasticSearch 2.3. That happened last week, I believe. Okay, so that makes it like usable. It was 1.5 up until last week. I don't know anyone that's still using like a pre-ElasticSearch 2 installation. So this is a good thing right now. We'll come back to the IAM policy in a sec. We're going to declare a module for ElasticSearch. We're going to give it a name. Okay, in this case, the name is NDC Sydney 2016, just to show that I've created one specifically for here. We're going to give it a data node count. Okay, so the new functionality in ElasticSearch in AWS allows us to declare master nodes and data nodes in the same way as you would in production. Okay, think of master nodes as the entry point into your ElasticSearch cluster. Okay, those master nodes are like they're the dispatchers. They're the ones that do all the work, and the data nodes are just empty data stores that you just keep attaching, and as your data grows, you just add more and more and more data stores in and attach them to the master nodes. Okay, we're not doing that this time just because I'm trying to keep it as simple as possible. So we're just going to say we just want one node, one data node. We don't care about zone awareness, so what that means is it's not load balanced. Okay, if you wanted to load balance, you'd need two nodes, because that's the way load balancing works. If you take one thing away, take away that load balancing needs more than one node. And lastly, we want an access policy. Okay. The access policy is who can talk to your ElasticSearch instance. I decided to make this public and wide open. So what I'm saying is that all actions on ElasticSearch are available for anyone in AWS. Okay, so when the output comes out the back, if you really want to, you can hit this URL. It'll probably cost me money, but that's okay. I'll take it back in beer tokens. And then lastly, we take an output of Kibana. Okay, so there's a module. We have 6 modules. Okay, but inside each module, we're doing lots of different things. So let's graph our infrastructure right now. Okay, because the order in which this has been done is slightly different to how we would actually create our infrastructure. For example, I have ElasticSearch last. That's probably the first thing that's going to be created in my infrastructure right now, because other pieces of information have dependencies on it. For example, the Lambda template has a dependency on the ElasticSearch node because it needs to grab the URL. So we can graph this infrastructure. Not a make. Oh, it's not in trash. No, I don't want to go to trash. It's definitely not in trash. Terraform dev. There we go, that's better. And if we Terraform graph it first, we can see that it's pretty complex and it has a lot of different pieces. Okay, that's garbage. Excuse me? A lot of access control stuff. Yes, yes. Just because everyone, as I say, everyone likes IAM. And lastly, if we just open the graph, we get a pretty picture. Okay, because now we're actually building the dependencies between our system. So You start at the top and you work your way down. Terraform will work out what it can, because of that graph theory, and it walks the tree every time, it will work out what it needs to do first, okay, and what has dependencies on each other. So you can see that it's got the archive file, it's got the S3 bucket, it's got the Lambda function, it's got the IAM role policy, it's got Kinesis stream. That has no dependencies on anything else, but the Lambda event source mapping has a dependency on so on and so forth. Who hates drawing? Who hates drawing at work? Why draw? This can do it for you. This is what I tweeted, and everyone was like, wow, it's serverless. It's not serverless. It's not serverless at all. It's just using pass. But the main thing is that this is living documentation. And if we Terraform plan, it will compare the state locally against what the state is in AWS. I'm really hopeful that there's not like it's going to destroy my infrastructure right now. But you can see that it's going through the entire list, and it's checking it one at a time, and it should tell me that there's maybe one change. That's yes, because 2 changes. Oh, we'll skip that one. That didn't happen. That didn't happen. Don't look. What that is AWS normalizes the JSON for access policies and IAMs. So sometimes it sends back like an array where you passed a string, and sometimes it sends back a string where you passed an array with just one element inside it. I haven't cracked that part yet. I will, I promise. But the main thing is I just renamed earlier index.handler to Kinesis Lambda es.handler. Okay. So it's going to tell us, it's going to give us a deterministic view of what it's going to change. Please, if you're going to use a technology like this or an infrastructure as code tool, don't just blindly apply to your environment. Always run a plan first so that you can see what it's going to change. Okay? And what you can actually do is you can Terraform plan out sydneydemo.txt, and it will save that plan as text so that you can see in GitHub or whatever source control you use what it's going to do when you've made those changes. So if we go and have a look in AWS, we can actually see if this worked. Firstly, I have a Lambda function, Kinesis ES Lambda. That has the configuration of index.handler because that's what Terraform told us it was going to change to something else. It has a role called IAM for Lambda, which I showed you here, IAM for Lambda. It has a trigger, which it reads from a Kinesis stream called log stream. Let's have a look and see if that's there. 13 minutes. And then now we're going to cut to the figures. Logstream has 5 shards. They're all open. We can see all the different metrics that we've actually applied to it so that we can get them inside CloudWatch. You want metrics. Metrics are good. Metrics are your friend. From there, we have the function. Yep. And then lastly, we have ElasticSearch itself. Okay. We have a domain of NDC Sydney 2016, ElasticSearch 2.3. The best thing is it's a green cluster. It's only one node. If it wasn't green, I'd be slightly worried. I'd be really worried, and it wouldn't work. But the main thing is, if we go inside the cluster, we can actually start to say, hey, look, there's one node, so there's one data node. There's no shards because there's nothing in there right now. We haven't pushed any data into it. There's no indexes. We're going to force an index in right now by opening Kibana. Okay? We have the monitoring. So cluster green, cluster yellow, cluster red, searchable documents, nodes, deleted documents, metrics. And then lastly, we can have a look at the access policy. The access policy is what we declared. We did it in a slightly different way because we declared it as statements rather than JSON. But it's gone off and built the JSON for us, where we have the resource and we have the action, and we can say everybody's allowed access to it. And it has templates if you really want to like copy some templates. I actually copied the template. So. And lastly, we have an endpoint. So our applications know where to send our data to. Okay? You need to if you actually want to send some logs. But more importantly, we have Kibana. Kibana is a dashboard that allows you to visualize and search documents inside your ElasticSearch cluster. This is bundled. And we actually can go and create our index patterns. Okay. So in 6 really simple Terraform modules that are connected together in the graph, we've deployed an entire logging infrastructure. Okay. Really simple. How would you push data into it? I'll show you in a second. Now if we go back and have a look at the cluster, it's going to be yellow because we have an index, and it's currently trying to allocate that index out across its replicas and shards. Hopefully it's yellow. Yes, it's almost as though I practiced this earlier. And we can go inside the indexes where there were none before, and we can see that there's a .cabana 4, there's 1, and the size in bytes is this, and it's got specific mappings. Okay. Serverless in action. Yes. Now, the code's all going to be on GitHub. I promise I'll post it and hashtag it NDC Sydney. Okay, you can go and have a look through it. There's nothing in there that's proprietary. I'm probably going to remove my AWS account ID. I have left so many account IDs and access keys on stuff. I gave a talk in London a couple of months ago, and I opened up an email. The talk was being recorded, and everyone could see my username and password for a specific tool that I use. Error, really bad. So how do you send information to Kinesis? Okay, on your application server. Okay, you can use Logstash, or you can use Beats or something. If you want to use Logstash, install the Logstash package and add those 7 lines right there. Okay, so you declare an output. The output is telling Logstash, I want to send this data where I'm reading it from to somewhere else. It'll be the stream name, it'll be the region, and you'll send it as JSON. It doesn't get any simpler than that as a Logstash output. Okay, so that's really key. So the costs. This is now where it gets interesting. So I told you before that my ElasticSearch cluster alone was approximately $25,000 a month. Okay. My entire logging infrastructure was $38,000 a month. Okay. It was pretty hefty. Okay. I probably would have added some more stuff to it just because I like saying, oh, I manage infrastructure at scale. It wasn't really at scale, to be honest. It was causing more problems than it was worth. So Kinesis streams are $0.15 US for every million put requests. Okay. We have 5 shards. 5 shards will cost, I'll come to that in a second. 5 shards are approximately like $50-something a month. It's $57.60 or something equivalent to that. 5 shards can handle 1.3 billion put requests a month. Okay, that's an input of 10 megabyte a second and a read of 20 megabyte a second. Okay, if you're going to use that, that's pretty cheap for 1.3 billion messages a month. Okay, Kinesis streams. If we want to hold the data for longer than the 7 days, it works out at $0.02 US per day, or per hour, excuse me. So you would have to do, it works out, the extended data for 7 days works out to be $59.52. Again, really cheap. You're probably not going to need to spend that $50 because if you're still having to read your log messages in 7 days' time, I'll reiterate, you've got some problems. Or alternatively, you probably shouldn't be logging it. Because if it's not useful to you and you're not reading it, why bother? Lambda. Lambda is 22 cents for every million invocation queries. So if we're going to push 1 million messages through Lambda a day, it's 22 cents, US cents, not Aussie cents. ElasticSearch is 9 cents per hour per node. Cheap. I'm using an M3 medium there, so it's a general purpose machine that's got 8 gig of RAM and it's got a couple of processors. It's enough in order to churn through Elasticsearch queries. And lastly, if you want to add some EBS volumes to Elasticsearch, to store, I think by default it comes with like a 4 gig SSD. You're going to want more data. You're going to need more size. It works out to be 13.5 cents per gigabyte per month. With the entire logging infrastructure I have put together in this GitHub repo, so I'm assuming 1 million messages a day. I'm assuming that I'm going to store the Kinesis data for 7 days, just in case my data lake needs to be filled from it, because that's the new cool thing to do. I'm going to push 1 million invocations through Lambda every day. I'm going to stick with one node. Is that right? Yes, one node, just because it's a dev setup or a local machine setup, or you're just testing this out. And I'm going to add 100 gig SSD, a general purpose SSD to that machine. The total cost is $144.87 a month. I feel like a salesman. I feel like this is like Amazing Discoveries or something, right? That is really cheap, okay? For being able to process 1 million log messages a day, as you're starting off at your company with centralized logging, if you can't tell me that you cannot spend $144 a day. In fact, you can cut that by $50 because you don't need the extended lifetime. I'm really trying to sell people this, right? This is ridiculous. But it's so cheap. It's like, I would spend that on coffee a month if I was out in London. Okay, London's a really expensive city. And it's like £6 a day, well, probably 10 quid a day for coffee, because I'll have a couple. I like caffeine. I can do that personally for my own personal projects. We should all start using this type of technology. All of these hosted services are available. I have used 3 hosted services in order to process the same level of data that I had 6 middleman services to get the data from my application server to my ElasticSearch cluster. This has it all. You could probably productionize this for probably, I reckon, in the region of about $400 a month. I posted this last night and somebody was like, yeah, 1 million messages a day is not a lot. I was like, it is if you're just getting started. You don't really go, and you're not going to want to go and spend $20,000 a month right now because you're not going to use that. Start small, let your application infrastructure grow in the same way as let your infrastructure architecture grow in the same way as your application infrastructure does. In Agile, we have this defer decisions until later. The same thing happens here. When you can use these hosted services, you can grow them, and you can add more nodes, and you can, the nice thing about Lambda is you don't have to go and tell Lambda, hey, I'm going to process 1 million requests. It's going to keep charging you for as much data as you push through it. The same for Kinesis. It's really cheap, folks. I have 2 minutes, 40 seconds. Has anyone got any questions? The man at the back. Can you just repeat it? I'm really sorry.
I'm very naive about all of this stuff.
Yep.
Would you consider CloudWatch logs as an alternative, or what are your thoughts?
Interesting question. So rather than using this, you could use like CloudWatch logs or something like that. I would use this because I can push many pieces of information through it. I can push CloudWatch logs into this. So I can make my CloudWatch logs searchable as well as my application logs. I can push metrics into this and then use something, so have Lambda emit stats.d events, okay, in order to push that to your metric server. So this is like think of it as like a Swiss Army belt, okay? You push JSON to it, it's going to stream it, and it's going to index it in Elasticsearch. Now, as you're starting in a centralized logging infrastructure, you're probably not going to know what you want to log, okay? But more importantly, you're going to want to know when you need to expand your infrastructure. A war story on this is in our Redis infrastructure, the first one that I showed you, an applicant, I was going to say something rude there, a developer actually DDoSed our own infrastructure, okay? Because he didn't realize that he had turned on trace debugging in his server. So it was sending, but the pieces of information he was sending were like 20 megabyte log chunks. So the infrastructure that I built by hand and loved like a China plate and gluing back together every so often wasn't able to cope with that. This is much more designed to be a little bit more elastic, and it'll churn through the data, because it's all platform as a service. Amazon are better at doing this stuff than I am. I trust them to get this right. If there's anybody that can get it right, it's probably AWS, right? So I would start with something that's really simple, and then if I need to change or I need to push more data through it, just keep growing and growing and growing. So CloudWatch log groups are a great way for your infrastructure in order to push information in. Have you ever tried to use the CloudWatch UI? I didn't say that, but good answer. Any other questions?
Yeah, just what do you use to monitor your logging? I know that probably says it. So you've got your...
What do I use to monitor my logging?
So you've got your centralized logging infrastructure. What are you using to monitor that centralized?
I've not run this specific thing in production. I used to use Sensu. Big fan of Sensu, just because it's a pull-based architecture. And before that, I used Nagios, which was horrid. So don't use Nagios. Sorry if anyone works for Nagios, but it's just really old, and it's not designed to scale in the cloud. It's designed for like a constrained data center that has like a number of nodes that are known. Okay, Sensu is more of a, when a node comes up, it checks into Sensu and says, hey, I'm a node of this type. Give me all the checks that I should understand, and it will perform them and send the data back. Use Sensu. It's probably my favorite one. There are lots of other tools out there that you can use, obviously. I just find it really simple, really, really simple. Any last questions? You're all free to go. Thank you all very much for your time. Enjoy the rest of the conference.